In this lesson, we'll revisit the question, can understanding the brain make us better learners? The answer is going to be a definite yes. In other lessons, we've seen a brain like this showing the two memory systems in the human brain, a sort of a short-term memory buffer, what we're calling working memory. And this involves whatever it is you're currently sort of thinking about or currently conscious of would be the contents of your working memory. And then we have the hard drive icon over here to represent the long-term memory system in the human brain. Now this would be all of the synapses in the cerebral cortex. So that is understood to be our long-term memory system. The short-term memory system is again a temporary buffer for information. We can manipulate information, but this seems to involve loops of neural activity, whereas the long-term memory system is related to synapses and the strengthening of synapses in the cerebral cortex. Now, importantly, whatever is in working memory can be stored in the long-term memory system. The brain areas that are processing a learning event not only share information with the working memory system, so we're conscious of it, but also send that information down to the hippocampus. The hippocampus will make memory traces of that information, and then those hippocampal memory traces will be used later during sleep and system consolidation to strengthen the associated cortical memory traces. So this process of consolidation then is what needs to happen if we are to have reliable long-term memories for the things that we learn. So if we now just boil down, what is this consolidation process? Well, it's when we're reorganizing our memories to make them less dependent upon the hippocampus for retrieval. So recently learned information, new information that we learn, we need the hippocampus to access the cortical memory traces. But over time, with system consolidation that occurs during sleep, we strengthen the cortical memory traces so that we no longer need the hippocampus for retrieval. Now, why do we do this consolidation process? Well, here are a couple of reasons. First, there are a limited number of synapses in the hippocampus. It's a smaller structure compared to the larger surface of the cerebral cortex. So we just have more synapses in the cortex to store more information than in the hippocampus. And with limited synapses, it means that we're eventually going to get to a point where new learning will interfere with memory traces already in the hippocampus. So we'll have interference due to new learning. Secondly, we have the synaptic resetting process that happens during sleep, and we do that to avoid reaching a plasticity limit. There's a limit to how strong hippocampal synapses can get, and so we must weaken them again so that they can be ready to be strengthened for new learning. Now, if you think about these two reasons for why we're consolidating, both are related to the idea of refreshing the hippocampus for new learning. So why do we consolidate? We've got to prepare the hippocampus for new learning. And another important reason is because we must integrate the new stuff that we're learning with all the old stuff that we already know. So we've got to take whatever we learn today and integrate that with information we have already encountered. We need to update our semantic memory, as it were. Now let's also consider the flip side of remembering, and that is forgetting. Why do we forget? And it's important to understand this concept of forgetting if we're trying to become educated. As we'll see, many students underestimate how much they will forget the information they're trying to learn. And if we go through a learning process and in the end we forget it all, then we have not really achieved our goal of becoming educated. So why do we forget? Well, one common idea out there in our culture is that learning is the storage of information in the long-term memory system, and forgetting is when that information decays over time. But we have a problem with this common idea out there. And that problem is that we've already learned that scientists think that the cerebral cortex is a good long-term storage site for memories precisely because the synapses, once strengthened, decay slowly. So scientists don't think that if you make a strong cortical memory trace that it decays quickly. It actually would decay slowly. These synapses take multiple activations to strengthen, but once they strengthen, they decay slowly, and that's what makes it a good long-term repository for information. So this common view of forgetting We've got to abandon this. It's a misconception that long-term memories decay over time, and that's what accounts for forgetting. Well, what is the science saying? The reality here is that there are two factors involved in forgetting. So we might fail to retrieve information if the information was not well consolidated in the cortical memory traces after learning. So we just didn't make strong cortical memory traces. And as a consequence, we then later failed to retrieve that information. Or the information was well consolidated, but not retrieved for long periods of time, causing a loss of access to the information. So there are two kinds of forgetting that we've got to be aware of. Let's take the first one again. Forgetting as insufficient consolidation. It may well be that after only one learning event where we make a strong hippocampal memory trace, remember during sleep that memory trace will be used to try to strengthen those cortical memory traces, but after only one learning event, we may still be left with relatively weak cortical memory traces. And so we later on will fail to retrieve. In addition, if during the learning episode we're not paying attention or we're suffering from high stress, these conditions can interfere with the plasticity needed to make a strong hippocampal memory trace. And so we may end up with just a weak hippocampal memory trace, which then, of course, is not going to be effective during sleep later on to strengthen the cortical memory traces. And again, we'll be left with weak cortical memory traces as a result. So for both of these reasons, then, we may suffer from poor retrieval if we have failed to make strong cortical memory traces and we're left with weak cortical memory traces. So that's one kind of forgetting as insufficient consolidation. But another kind of forgetting can happen. Here, in this case, we have gone through a good learning process. We've used good techniques. We've got strong cortical memory traces for the information that we have learned. However, over time, information can get lost. So when we don't retrieve these memory traces for long periods of time, it's as if the brain loses its ability to find this information amongst all the other memory traces storing all kinds of information in your semantic memory. If you don't retrieve this information, your brain can lose access to that information. And so we end up then with poor retrieval, even though the cortical memory traces are strong. And we think this describes a real situation, because if we now just take a moment to relearn this information, we can reestablish good retrieval of that information. So it's as if the memory traces were strong and they existed, but we lost access. Well, how can we guard against the loss of access? Well, to practice retrieving information. So practicing retrieving information does two things. It helps the brain strengthen the cortical memory traces, but it also strengthens the retrieval pathways so the brain can easily find the information we want. Now, here we're going to introduce another way of thinking about memory, and this is from the lab of Robert Bjork. He calls his lab the Forgetting Lab, that we've got to consider two memory processes when we want to become good learners here. And he identifies them with these two concepts: storage strength and retrieval strength. Storage strength is a measure of the strength of the long-term memory. And this would be in the cortex. It's a measure of how strong are those synapses in the cortical memory traces. Retrieval strength is a measure of the ease of access of information in memory, but this applies both to short-term memory or long-term memory. So retrieval strength just refers to how easy, how fast can you access this information. Now, is there a relation between storage strength and retrieval strength? And the answer to that is going to be yes, according to Bjork. Bjork argues that storage strength determines the rate of loss of retrieval strength. So here are two examples of that. With strong cortical memory traces, the brain is slow to lose access to those memory traces. With weak cortical memory traces, the brain quickly loses access to them. We can show this graphically with this graph up top here. We have on the y-axis rate of loss of retrieval strength, and the x-axis the storage strength. Notice then when storage strength is low, the rate of loss of retrieval strength is high. When storage strength is high, the rate of loss of retrieval strength is low. But perhaps it's easier to rewrite the term here on the y-axis. Instead of rate of loss of retrieval strength, let's just say rate of forgetting, because this is one form of forgetting. We've lost access. And so again, the idea is if we have low storage strength, so we didn't really strengthen those cortical synapses very much, we're going to have a high rate of forgetting. If we have high storage strength, so we really strengthen those cortical synapses and we've got strong cortical memory traces, then we're going to have a low rate of forgetting. And we should note then that well-educated people then, of course, are on this part of the graph. They have gone through a learning process that has increased storage strength, so they've used good study techniques to maximally strengthen those cortical synapses, and so they're going to have high storage strength, which means low rate of forgetting. Well-educated people, it's not that they just learn something, but they can reliably access that information, right? That's what it is to be educated. Yes, there are some people who go to good schools and whatnot, but if they don't use good study techniques, they might have a degree from a good school, but they aren't going to be educated, as it were, because they're not going to have access to information. And that would be these folks up here, right? So if you're using poor study strategies, you are going to end up with a high rate of forgetting because you have only achieved low storage strength, which means that you're going to be forgetting that information quickly. So in the next part here, we'll use these concepts of storage strength and retrieval strength to take a look at some common misconceptions about studying. And if we can avoid these misconceptions, we will be better learners.